Welcome to Wildcat Science with Mrs. Haugo. This is Physical Science, Chapter 1, Forces, 1.3, Hooke's Law and Proportionality. So today we're going to start out taking some notes, so please open up your binder to the Notes section, and in the table of contents, we're going to scroll down and go to 1, and please add 1.3 Hooke's Law, Proportionality, and then put it on whatever page you left off with your 1.1 introduction. Just make sure to skip 3 lines. So then let's go to that page in your notebook and skip 3 lines after 1.1, and please write chapter 1.3, Hooke's Law and Proportionality. So let's talk about proportionality. A proportionality is a relationship between two variables. Usually when x goes up, y goes up. So let's look at what that would look like on a graph. So looking at the graph, and I do need you to draw this graph. It's a pretty simplified diagram. We've got x-axis and y-axis, and then here is our relationship, our proportionality. You can see as x gets bigger, y gets bigger. There is a linear relationship between these two variables. So your book and Professor Mack both talked about a proportionality constant, which is the ratio of our two variables, and on this graph it's also the slope. So it is the ratio of two variables, like y over x, which is like slope. And you guys all know how to calculate slope. It's the change in y over the change in x. So let's go through an example, and please write this down. Example 1, you have a distance of 20 meters, so that would be our change in y, and a time of 10 seconds, and that would be our change in x. So what is the ratio of the two? So when we divide those out, we get 20 divided by 10, 2 meters per second. And if that sounds familiar, it is because that is a speed, which we just calculated, 2 meters per second. Our proportionality constant on our distance versus time graph would be 2 meters per second. So also there was another example we're going to go through, so please write this down. In your book, there was 7.5 millimeters of stretch for every 1.0 special unit of water weight. So whenever we increased our x or water weight by 1, the distance or the stretch of the spring would go up by 7.5 millimeters. So what is our proportionality constant here? Well, when we divide these out, we get 7.5 divided by 1, or 7.5 millimeters per special weight unit is our proportionality constant. So let's talk about Hooke's law. Hooke's law is a proportionality between the stretch of a spring and the force acting on it. And our proportionality constant is going to be equal to the stretch divided by the weight. And let's take a look at our graph. So we're going to make this graph in our notebook. Please draw this out. So in our x-axis, we have weight in newtons, and it's going to go from 0, 1, 2, 3, 4, and 5 newtons. And then in our y-axis, we have our stretch in meters. So this is a very big spring. Goes from 0, 1, 2, 3, 4, 5, and 6 meters. So we have some data to graph. At about 1 newton, we had roughly a 2 meter stretch. And then at roughly 2 newtons, we had roughly about a 4 meter stretch in our spring. And then at 3 newtons, we had roughly a 6-meter stretch in our spring. And then we draw a line, the line of best fit. It doesn't go through all the dots, but that's okay, for our graph. So my question is, what is the proportionality constant of this graph, which is our stretch divided by our weight? So to figure that out, we would take a point on the line. So let's say about 6 and 3, our change in y is 6, and our change in the x direction is 3. 6 divided by 3 is 2. So 2 meters per Newton is our proportionality constant. Okay, great. That concludes our notes, and now we're going to move into our 1.3 questions. So please find your Chapter 1 questions, that was a Google Doc, in Classroom, and open that up. You should be done with number 1, and we're going to postpone 1.2, so we're going to, for now, skip 2 through 5, and we're going to go down to Hooke's Law, proportionality, number 6. So using your own data, make a table similar to 1.2. Then graph the total stretch versus total weight. And A says fill out the table from page 6. So you'll need to get your book, Force, Motion, and Energy, and open it up to page 6. And there is the table 1.2 is at the bottom. And as we can see, I'll start filling it out, and then you'll have to finish it on your own. It goes 0, 1, and 2. And these are all special units. Then you want to fill out the rest all the way up to 5. And then the stretch at 0 is 0 millimeters. And at 1 special weight unit, it is 7.5 millimeters. And then at 3, at 2 special weight units, it's 15.0 millimeters. And then you'll have to fill in the rest. And then after you're done with A, so you want to pause the video until you're done with A, and then we're going to make a graph using the graphing website, which we will do together. Okay, we're going to be making a graph using this website, and there will be a link for it in Classroom to make sure it looks like this. And we are going to be starting out by picking our type of graph. We're going to make an XY graph. So we'll pick that one. So we're doing an XY, and then our XY type is a line. And then we'll switch to our data, and we will enter our data. Our graph title, well, that's going to be our information from back here, which is total stretch versus total weight. Let's do verse total weight. And our x-axis label, well, that's going to be our total weight on the bottom. And it's in special units, so you want to make sure that you fill in your units. And our y-axis is going to be our total stretch in millimeters. I think we're going to leave source blank, and we're going to have 6 points. And now we can probably leave all this as is. And then our points are going to come from our table. So our point 1 is going to be our 0, 0. So point 1 is going to be our 0, 0. We'll enter that in there. 0, 0. And then our point 2 is going to be our 1 and our 7.5. And point 3 is going to be 2. And you want to check your table to get your numbers. And then 15. And then point 3 is going to be 22.9. And 0.4 is going to be 30.2. And 0.6 is going to be 5. And then 37.7. So our minimum x value is going to be 0, and our minimum y value is going to be 0. And then our maximum x value is 5, and our maximum y value, let's make it 40, a nice even number that's bigger than 37.7. Okay, then come on over to the preview button and hit the preview button, and it should have this graph. And let's just go over. It has a title, total stretch versus total weight. And in the x direction, we have a label with units, total weight, going from 0 to 5. And then we have in the y direction, total stretch in millimeters, going from 0 to 40. And they are marked out every 8, or each box has a division, has a value of 4. And we've got our nice line there with our proportionality constant if we figured out the slope of the line. So what we're going to do is we're going to put this in our Word document. So I am doing a right click and I'm going to copy the image, and then I come over to my Word document, and then where it says insert the graph here from the website here, I'm going to do Control Paste, and there I have it. Did it work for you? Now you have a nice, beautiful graph. So we're ready to move on to C, which if we scroll up and look at the directions, does your graph represent a proportionality? Well, we know a proportionality means there's a relationship between the two variables. So let's look at our graph. When x, or our total weight, goes up, does our total stretch go up? So you want to take a minute and answer that in C. However, it looks like our C got eaten up with entering the graph, so you want to make sure that's C and then enter it there using a race sentence, starting out with my graph represents a proportionality because, and explaining that. Now we're ready to move on to D, so scrolling up to the directions. If it does, what is the proportionality constant? Calculate the proportionality constant. Well, we know that our proportionality constant is our variable y, or change in y, over our change in x. So proportionality constant equals the total stretch over the total weight. And then we have to enter our numbers here and get an answer. So let's look at the graph. We want to pick a place that's nice and easy to read. So there aren't any points that go exactly through the diagonal of the graph. So we can cheat a little bit because they did give us our coordinates. So we know at 2 it's going to be 15. It's a little bit smaller than our line here. It's a little under the line at 16. So our total stretch is, at this point, is 15. So I need to go in here carefully and enter 15 millimeters, and then I use my right arrow to go to the end, and it goes down to the bottom of the fraction bar for me. And I'm going to enter in my 2 special units. So now that we have entered that, we will calculate it, and 15 divided by 2 is 7.5. And then our units also we need to divide, millimeters per special unit. And then we need to put it in a race sentence. The proportionality constant is 7.5 millimeters per special unit. And make sure you enter that. Okay, I think we're going to pause there, and then tomorrow we will finish up our questions. Bye.